Algebra 1, Unit 2, Understanding Functions, Module 3, Functions and Models, Lesson 3.1, Graphing Relations. In your notes, you should have this right here, so you should probably go through them, right? And you'll find the answer at the um, bottom of the page. Okay, for these, we could, you could come see me during class, you know, and we could go over it one-on-one. But essentially, if you follow the direction over here, guys, the key is that for it to be proportional, it has to go through the origin for question 1 and 2. And for this one, for it to be a linear function, it has to meet these three things, right? Three requirements. And here's the answer, guys. First, number one is no, because it didn't go through the origin. This one's yes, because we went through the origin. And let's talk about why that must be the case, right? The reason why it is proportional is if you, let's say, a line goes through the origin like this, and there's a point x1, y1, which is this length and this length, right? x2, y2 is x2 here and y2 over here. You'll notice that these two triangles are proportional, right? So the ratio of y1 over x1 must be equal to x2 over, y1, y2 over x2. Yeah, that's it. You know, if you try to do the same thing and it doesn't go through the origin, the value of the coordinate cannot be used as the as the to set the proportions. Okay, so that's the main difference. Alright, guys, let's look at these two. The first one is yes. This one is 4 is no. I labeled this A, B, and a C. That way I don't have to write out the entire sentence, right? So for number 4, it is no because of the statement B. X and Y are not to be multiplied together. In this case, it is being multiplied together, right? For number 5, right here, answer is no because of C. X and Y do not appear in the denominator, exponents or radicands. In this case, x is appearing as uh, one of the exponents. Okay, guys? All right, and this is the warm-up that you should do. Okay, the main thing that I want to just talk about is actually the physics of this. Now, this is a melting point, and this is the boiling point. So after it boils, it becomes gaseous. Uh, Below the melting point, it is solid state, right? And then between the melting and the boiling is a liquid form, liquid state, right? So these are the transition temperatures, right? So for something to be in a liquid state, right, it would have to be in between these two, right? And it might be in your best interest to find the length of that for how long it is in a liquid state. Yes? Okay. All right. Why don't you pause this video and finish up the rest of the warm up. All right. I'm going to assume that you finished your warm up. Here we go. And basically, what we're looking for on the left hand side is basically this right here. The G, the temperature for the gold, is between these two values. That pretty much was it. And you do that for every single one of these, right? That'll be C, I, L, and A. And then you just estimate where it is and graph it. Make sure you do not include the endpoints because those endpoints are transition points, so you don't want to include them. And here the range was 1792. When you subtract the high and the low, that is the boiling temperature minus the melting point temperature. And what you will notice is that this is the largest length. It spans the greatest amount of temperature to be in the liquid state. And then 1323 is the smallest, so the iron is the liquid state for the shortest values of temperature in centigrade. And another interesting thing is that the lead, right, becomes a liquid state at a lowest temperature, and it becomes gaseous at also the lowest temperature out of any one of these. All right, so that's what you have to basically describe right here, guys. Okie dokie. All right, guys. So let's get started with this one. All right. In this particular case, this was done as a quasi group working class, but this graph is distance a delivery van is from the warehouse varies throughout the day, and the graph shows the distance from the warehouse. So this is like what, 8 in the morning till 5 p.m. And looking at this graph, you need to say, hey, what's going on here? Okay. Why don't you guys, for those of you who are not in class, try this the best you can. And yeah, pause the video, please. Okay, so coming back, yeah, if you sort of think about this, there are a couple of things that you need to sort of keep in mind. That if, as time goes this way, if distance is increasing, we could say that the van is moving away from the warehouse, right? So if it's coming down, the slope is coming down, slope is negative. You're coming back towards the warehouse. And if it's flat, horizontal like this, or slope is equal to 0, the distance is not moving. So that's what you have to describe. So with that premise, you could actually answer all the questions. In A, by the way, feel free to stop the video anytime you like to try to answer the question before I explain it, okay? They're asking you to compare 1 and the 2. Well, they're both moving away, but what's the difference? Well, this is a little flatter, isn't it? If it's completely flat, like horizontal, it's not moving. If it's coming down, it's coming back to the warehouse. So 1 is moving further away, and 2 is also moving away, but because it's a little flatter, it's actually slowing down. Do you see that, guys? All right. Based on time frame, what change in the distance from the warehouse is represented by 6? Yeah, because the slope is negative, it's coming back, right? All right, guys, see if you could answer the rest of the question. Okay, and here are the answers. A is moving away because the y value, so the y-axis value, the miles is increasing, or because the slope is positive, it's positive slope, and it is slower than segment number 1 because it's a little flatter. B, van is coming back towards the warehouse because you have to justify it. The value, the y value, right, is coming down, or the graph is pointing down, or we have a negative slope. Okay, and the C, which segments show intervals where this did not change? That'll be 3, 5, and 7, and the reason is the distance remains the same because the line is horizontal, the graph is horizontal. And D, how'd you describe the segment from part C? We would say that truck is not moving or has stopped. That would be the most apt description. And the last one, not least, is basically the premise with which we did this problem. When you're moving away from the warehouse, slope is going up or positive, or y value is increasing. Talking about the y-axis, right? When you're coming closer, when slope is down or negative, right? Negative slope, or the graph is coming down, or we could say that y value is decreasing. So those are the slightly different way of describing all this. It's not moving when the graph is either horizontal, or you could say that slope is equal to 0. Okie dokie, guys. All right. So let's go to the next page. Let's talk about this. So there are 3 hoses, right, that are filling the water barrel. The green hose fills the water at a constant rate. The black hose is slowly opened when filling the barrel. Um, and then blue hose is completely open in the beginning and slowly closes. Okay? So black hose is slowly opened. I think it means that it's opening wider and wider and wider as time goes by. Given those graphs A, B, and C, which ones describe the other? Oh, three different hoses. Can you try to work it out on your own? Okay, I'm gonna assume that you already paused the video, and let's think about this. Okay, so think of this part as a hint. What I would do if I were you, it's like maybe there's a beginning, and the middle, and the end, and choose like 3 points throughout the graph. Let's do that, shall we? So what you could do for the graph A is maybe choose this point, and this point. And you're going to draw a tangent line, right? When you do that, what do you see? The tangent line looks like this, tangent looks like this, tangent looks like this. So those are the tangent line. Tangent line is, or slope, is when a line is touching the curve at a single point, right? So if you're throwing a baseball, at the top, the point of the release, the ball will go in tangent line. Okay. So yeah, what do you think? But before we begin, the thing that I want to talk about, because the word slope was alluded to earlier. So in this case, what is a slope? Slope is change in y and change in x, as you might have learned in the previous year. And the change in y is a change in water, the amount of water. And change in the x direction, that's time. Change in time. So what would you describe the change of water coming out of the hose over a period of time? What would you call that? If you skim down, I believe there's a word that's used. Oh, flow, right? So that I would call that the flow rate, right? So the slope is synonymous or equal to the water flow rate. Okay, now let's look at A. What's happening? As time increases this way, my slope is a little flat, my slope is a little steeper, and then it got steeper even more so, which means the water flow rate is increasing, isn't it? And then you take 3 different points over here, and what do you do about all these 3 slopes? They're exactly the same. So the flow rate, the water flow rate, did not change as time increased this way. How about C? Right, choose maybe 3 points at the beginning, towards the middle, and towards the end, right? So we have this slope, we got this slope, and we got this slope. So slope was kind of steep over here and kind of flattened out a little bit, flattens out even more. So as time increases this way, my slope is decreasing, or my water flow rate is decreasing. Now, given that, try to answer the examples A and B. Okay, so I'm gonna assume that you have paused and then unpaused the video, and here are the answers that I went over in class. All right, as I said, here as the t goes to infinity is a fancy way of saying increases. As time increases, slope is increasing, and that describes the black hose, because the black hose is having the barrel is slowly opening wider and wider. Therefore, the flow rate will increase, right? And then for this one has to be green, because the green one says it's a constant flow rate. And blue, this one is blue because it's completely open at the beginning and slowly closed. So meaning it's decreasing, right? So that was it. So this is black, green, and blue hose. To answer the question, sorry, A, right here, guys. So which one best describes graph B, because slope is constant and does not change? So that would be the green one. Part B, describe each one of graph A. As time passes, the rate, slope, increases. Flow rate, right? So that'll be black hose that is opening wider to increase the water flow. And describe the water level for the graph C as time passes for that one. The rate, the slope, decreases, meaning that the blue hose that is being slowly closed to decrease the water flow. Okie dokie. All right, guys. And then we got one more page of the note. Here we go. When you're copying this down, please write this down. In the first one, where in a real world situation, the graphs are drawn without any interruptions. Some graphs are drawn without any interruption. In other words, they are continuous graphs. So continuous graph is a graph that's made up of connected lines or curves. Here, guys, connected lines or curves. And there are another type of graphs that are not continuous, and they are made up of distinct and unconnected points. These are called discrete graphs. Okie dokie. Alright, guys. So we got example 1. Sketch the graph of the situation. Tell whether the graph is continuous, discrete, or whether the domain. Determine the domain and range. Uh-oh. Okay, so we just described continuous and discrete, but what is domain? Do you guys remember from last year? Right, if you said that is the x value for the xy coordinate system or graph, you're absolutely correct. And x is what we call the independent variable, right? And that is the input value. Input value. If it's a function, that's what you put into the function to get the output value. And so that begs the question, what is a range? And if you said y value, that's also correct. And similarly, that would consider the output value. Output value. And y would be the dependent variable. Okay, in this particular case, a student is taking a test. There are 10 problems in the test, and each problem is worth 10 points. No partial credits. That's it. You get a bunch of dots, right? Here, 0 through 10 questions. Here, 0 through 100 points, right? So now it's asking you to, the graph is discrete because it's made up of multiple unconnected points. The domain, the x value, is the whole number from 0 to 10. Or it could be written as, by the way, starts with 0, 1, 2, ... 10. When you write a lot of numbers, right, you should write about 3 to 4 numbers to establish a pattern, right? So here, to set pattern, clearly numbers going up by 1, starting with 0. When you go ... it means you're going the same exact pattern. So it'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you always want to write down the last number. Okay? So that's a fairly common convention that we use. Okay? For the range, it's a whole number multiple of 10 from 0 to 100. That is correct. And you might, in eagle eye amongst you, would have noticed that Mr. Yim should not be R because it's a range. See that range? Domain is a D, and you're absolutely right. And once again, we set the pattern starting with 0. The next number is 10. You get 1 question right. You get 2 questions right. Worth 10 points each. With 20 points. So we establish a pattern that number is going up by 10. And we go ... We continue that pattern until we reach 100. Okay. Minimum 3 numbers I would recommend to establish a pattern. And sometimes, if it's a more complicated pattern, you may need more than 3. But I think for Algebra 1 and most of the Algebra 2, 3 is sufficient for almost all of the questions. Okay, let's get part B. This is the one that requires a lot of reading. Why don't you take a time to read example B. Okay, here it's bathtub. Water's coming out. using our common sense, do you think this is discrete or continuous? So in order for it to be discrete, the water has to come out, then stop, come out and stop, come out and stop, right? But that's not the behavior of the normal bathtub when the water is coming out. It's continuous, right? So it has to be a continuous line. And most of the time when you turn it on, it usually comes out at a constant rate. What that means is that it's going to be a straight line, as we saw in an earlier example. Okay, let's try to graph this, shall we? After 10 minutes, there are 75 quarts of water in the tub. That's first point. Well, we would start with 0, 0, right? Exactly. And then we'll run continuously for 10 minutes. That's the x-axis. For 75 quarts, that's the y-axis. Let's do that. The first point will be 0, 0. 10 minutes is here somewhere. And I believe you said how many quarts? 75 quarts, which should be right between the two. Is that right? Yes, it is. Leave another point right there. And then draw a straight line, guys, like this. And it's probably a good idea for you to use a straight edge, right? There you go. So it went from 0 to 10. All right. What happened next? Somebody accidentally pulled the drain plug. Uh-oh. It means it's decreasing, right? While the water's still running. So the tub begins to empty. Tub loses 15 quarts for 5 minutes. Oops. What I want to do is actually it went from 0 to 75 quarts, right? So 75, it lost how much? 15 quarts, right? Minus 15 gives you what? 60? Right, in the next 5 minutes. 5 minutes is right there. 60 is right there. That's the intersecting point right there, right? There you go. Oopsie. There you go. So, you know what? I want to underline that right there. And let's say that's 2 minutes. Sorry, 2. And then somebody plugged it back in, fills for 6 more minutes, and gains 45 quart. Okay, so we had 60 quart. We're going to add 45. That's 105, isn't it? And I believe, if I'm not mistaken, it's right there. And then if you go 15 minutes to the add 6 more minutes, that's 21 minutes. 21 is like right here, isn't it? A little bit outside, so it goes up to this point. So that's a straight line right there. Yeah. And I believe I'm going to say that will be 45. That'll be number 3 right there. So that's a third line that we have. Okay. And after that, you take 15 minutes of bath. The implication over here is this, right? When you're taking a bath, right, after you get all the waters in, do you putting any more water in? And the answer is no, right? All right. So at 21-minute mark, we're going to go another 15 minutes. So what is that? 21 plus 15 minutes. That gives you 36 minutes, right? Which is about here. And it's going to remain the same right here. So that's going to be 15-minute bath. That's number 4. That's fourth information that we used. Sounds good? And the last information is that it took 11 minutes to drain. Okay, 36 plus 11, that's 47 minutes. At the 47-minute mark, which should be about here, because that's 45 and a little bit past. Yeah, that's right. And then it goes all the way to 0 at that point, right? So that is 5. When he says drain, no more water, right? And that really is it. So sorry about me being inconsistent with color here. Let me change that to all blue. There you go. So that's what the graph looks like. So it goes up, and then it goes down a little bit because the drain was unplugged accidentally. It goes up again, and that slope looks about the same. Then you turn off the water to take a bath for a while, and then you unplug and go straight down to nothing. Sounds good? All right, guys. Now the question is, the graph is what kind of graph? What is my domain and what is my range? Okay, guys, pause the video, try to fill that out. Okay, You're back, so here we go. The graph is continuous. It is, domain is from t, so 0 is less than or equal to t, the time, less than or equal to 47. Starts at 0 time, ends at minute 47. Okay, 47th minute. And the range, amount of water W, oh my gosh, I just realized, sorry about that. It says Q, so I have to respect that. I should use the letter Q, all right? So Q starts at 0 and ends at 105 because that is the highest value, from 0 to 105 this way. Okie dokie. All right, guys. So we have your turn over here and over here. Please pause the video. Okay, here's the answer for number 3 and 4, and for number 5 and 6. Okay guys, that wraps up the video. That's what I did today. And for those of you who are absent, I hope you take advantage of this. And for those of you who wanted to see the video, here it is for you. Alright guys, I'll see you again next video, okay? Have a good night.